Hello everyone and welcome back to PU2 Brahmastra Series in our channel Diksha Karnataka. Right? You are watching this series for betterment of your PU results. I hope you are enjoying this series. We are discussing chapters, important chapters, and from there are important questions based on the blueprint. Right? So today I am going to discuss about the chapter alternating current. We also sometimes call it as AC, right? And sometimes we also call it AC current, but it is a redundant word. AC itself has the term current in it, so but we allow it. Okay, we don't have any problem mentioning that AC current, DC current, but AC current means alternating current. That does not seem good, right? So better you say alternating current as a one word, right? So just jokes apart, this is a very important chapter, and if you want to ace that numerical problem from your PU board exam, then this chapter is a must watch. Okay, today we will be discussing, the video will be very short, but the lecture will be very important for those who are struggling to score marks in the numerical problems. Okay, if you just watch the numerical section from this video, that will clear your entire doubt of all the numerical problems that might come from this chapter. Okay, so first of all, obviously our schedule we have already completed all the green portions. Today I am going to discuss alternating current, and tomorrow maths and bio integration 1 evaluation, and Sunday will be maths only integration part 2. So everything will be covered throughout this week. Next week schedule we will be giving you next week, right? So without any delay, let's see the blueprint of the chapter. As you can see from this blueprint that there is only one MCQ coming in each of the topics, okay, and one fill in the blanks in each of the topics, right? And if you see the numerical problems have one HOTS question, one application questions, one HOTS question again, and they are all numerical questions. Okay, there is no questions in between, so there is no 2-mark question, there is no 3-mark question, there is no 5-mark long answer type question from this chapter. Okay, so only MCQ, fill in the blanks, and long answer type questions that will come from this chapter. No short answer type questions, no small questions will come in the PU final board exam. Okay, there are sometimes they ask some questions in your preparatory exam because that was set by the district administrations. Okay, sometimes the teacher who is not aware of the latest blueprint, they might sometimes add a few questions from the 2 marks or 3 marks question. Okay, but you can assure that be assured that there will be no question from this chapter for 2 marks or 3 marks in your final board exam. Okay, now let's start with the questions that we are going to discuss in the lecture. So we will be discussing 15 MCQs as usual. We will be also discussing 5 fill in the blanks question, and then we will discuss 5 very important numerical problems from this chapter. Okay, in case some more extra numericals required from this chapter, I will make a video later part of the series. Okay, when we are at the end of the series, where we are basically discussing some specific numerical questions that we can do in our later half of the lecture. But right now these 5 numericals are chosen specifically for your board exam, so don't miss out on a single question from this lecture. Okay, all the 5 questions are very important. They will change the values, but the questions will remain the same. Okay, so be careful, but values you can adjust, but concept you cannot. Concept you have to know, then you can adjust with the values, right? Now let's start with numericals. An ideal step up transformer decreases. So ideal step up transformer, first let us understand what is the meaning of this. Ideal step up transformer generally increases the voltage. Okay, so if it increases the voltage, then it will decrease the current. Okay, so it will decrease the current. Power in an ideal transformer remains constant, frequency does not change, only thing that change is current and voltage. So they actually interchange between them. If you increase the voltage, current will decrease. If you increase the current, voltage will decrease, like that. Okay, so in step up transformer, current decreases, in step down transformer, current increases. Okay, and vice versa. for voltage. Okay. Next question, in a transformer, NP and NS are the number of turns present in its primary and secondary coils. We already know that NP is basically means that number of turns in primary, NS is the number of turns in secondary. Okay, respectively. The transformer is said to be a step-up transformer if. So, if it is a step-up transformer, then turns in the secondary should be more than the turns in the primary. That is the primary condition. So, the number of turns in secondary should be more than that of the number of turns in primary. In other words, number of turns in primary should be less than that of the number of turns in secondary. Okay. So, option A is correct. Question number 3, in a transformer, the windings of the primary and secondary coils are wound one over another to reduce the energy loss due to. So, in a transformer, sometimes the coils are wound like this and then this through some core. Okay, there will be some core involved, but why they are wound like this? Wound means the spiraling on a surface, right? So why they are connected like this instead of connecting into the standard any other forms? Okay, the main reason is to stop flux leakage. Okay, because the flux which is connecting the two coils primary is driving force. So from the primary the flux is linked with the secondary, and then the current is induced in the secondary. So we don't want to lose too much energy in that. So whatever energy is whatever flux is given to the secondary, that entire flux should be given to the secondary, right? Some flux will go outside, but because we know that magnetic field lines are not uniform always, so they will move like this. So if you don't link the flux together, then flux will leak. So basically this is to stop flux leakage. Okay, question number 4. In the case of alternating voltage applied to a resistor, okay, so alternating voltage and only a resistor, nothing else is mentioned, right? So we can assume that it is a simple R circuit, but you are applying AC. So basically, for example, our normal electric heater, okay, if you are using electric heater, that is a resistor connected to an AC. So what is the options given? The current leads the voltage by an angle of pi by 2. Current and voltage are at the same phase when only a resistor is connected. Okay. The current lags behind the voltage by a phase angle of pi by 2. Incorrect. The current and voltage are in phase. Yes, current and voltage are in phase, are in same phase or are in phase. Both are same term. Okay. So don't confuse if they mention that current and voltage are in same phase. Same phase or in phase, they are the same term. Current leads the voltage, obviously this is not correct. So from this option we can see that option C is correct. Question number 5, the average power dissipated in an AC circuit is maximum if the AC source is connected only to a pure resistor. Okay, power dissipated means whatever power you supply, that entire power is absorbed. So that happens only when the circuit is connected to a pure resistor. Okay, in case of pure inductor and pure capacitor, no power is consumed at all. So that's why they are called wattless current, if you remember. Okay, we will see that in a while. The power factor for a pure capacitive / inductive circuit. So this is a question where they can ask you the power factor for pure inductive circuit, power factor for pure capacitive circuit. Okay, so power factor and power for capacitive and inductive, both cases are 0. There is no power consumed, so power factor is 0 for both the cases. Okay. The resonance phenomenon is exhibited by a circuit only if the following components are present. Okay, so resonance phenomenon, if you remember resonance frequency, formula for resonance frequency is 1 by 2 pi square root of LC. Right, so formula for resonance frequency is 1 by 2 pi square root of LC, right? And in terms of angular frequency, it is 1 by 2 pi only LC. angular frequency or angular speed, it is only 1 by root LC, okay, but in terms of frequency it is 1 by 2 pi LC. So what are the components required? Is there any R involved here? No R is involved, only L and C is involved. So resonance happens only when L and C both are connected, okay. R is not compulsory. R is basically regulates the current, otherwise there is no necessity for R to produce resonance, okay. Question number 8. Now this also has a 2 versions, so that's why instead of giving 2 different questions, I have included both of them in a single question. The relation between the peak value of current and RMS current is, so IRMS is basically 1 Im by root 2, okay. So don't get confused, okay. People sometimes get confused between this and this, okay, but it should remember that IRMS is equals to maximum current divided by root 2, okay, maximum current divided by root 2, okay. And whenever we mention, if we don't mention anything, that means that current actually is a RMS current or RMS voltage, okay. So if we say that 220 volt power supply, 220 volt power supply means it is a RMS voltage, okay. If nothing is mentioned, that means it is a RMS voltage. If they mention peak value of the input voltage is 220 volt, then that means VM. Be careful, okay. This chapter has some certain twists that you have to remember. The relation between the peak value of voltage and RMS voltage, same question again, the answer will be VRMS equals to VM by root 2. They can ask you the question on RMS current, or they can ask you the question on RMS voltage. Sometimes they will reverse this option, so that also I am telling you, okay. They will reverse this option. How they will reverse this option? They will say VM equals to VRMS by root 2, VM equals to root 2 VRMS. Now in this case you have to choose this as your correct answer, okay. So they will reverse the right and left side, so in that case you have to be careful and don't fall for the trap they want you to fall for, that is VM equals to VRMS by root 2, okay. No, VM is not VRMS by root 2, but VRMS is VM by root 2. You remember only these two. You remember this one and this one, okay. Obviously if this one you remember, you can calculate the other one as well, but if they reverse, if they change the option, you should be aware that okay, this is a trap, I should be should stay away from it, okay. Next question. The relationship between the peak value of IM and the current and the RMS. Oh, this is the same question. Yes, this is the same question. Sorry for that. This is the same question. Next question. The input voltage to a pure inductor is V is equal to Vm sine omega t. So what is the circuit? Pure inductor is there, okay, and the input is Vm sine omega t. Then the current in the circuit is, so how can we find the current in the circuit if the voltage is given? All the terms are of the same meaning, right? Now we know that in a pure inductor, current lags the voltage by an angle pi by 2, right? So current lags the current voltage by an angle pi by 2. So this is the only case where current lags, so this is the answer, okay. In these both cases, this is same phase, in phase, which is not possible. Here it is leading, that is also not possible, and this is also something else. Cos is given, so phase is also another pi by 2 more, so that is not even possible, right? So only option is Im is equal to sine omega t minus pi by 2. This is also can be given by I is equal to minus Im cos omega t, because if you convert it into cos, then this will become a negative cos, right? So you have to be careful, either of these two options will come, okay. This is directly taken from your book, this is slightly reorganized again there in your book also, okay. Both of them are directly from the book, so it can come, okay. So the direct formula may ask from the book, okay. Next question. The input voltage to a pure capacitor, same question. Now instead of inductor they have given you capacitor, okay, is V is equal to Vm sine omega omega t, then the current in the circuit. Now what is the answer? In case of capacitor, the current leads the voltage by a phase pi by 2. So in this case the answer will be option B. So same question, same option, only thing they have changed inductor and capacitor. Okay, so be careful. If it is capacitor, current leads. If it is inductor, current lags behind. Okay, so be careful. Similar question, similarly you can this can be written as I is equal to Im cos omega t. There will be plus, no minus sign. Okay, next question. In a series LCR circuit, the L and C are interchanged. The resonance frequency of the circuit will. So in a series LCR circuit, we know that there is a L, there is a C, there is a R. Okay, that's why it is called LCR. Now what they have said, you have interchanged the L and C. So now C is first, now is your L, now it is a resistor R. What will happen to the resonance frequency? That is the question, right? Now does it depend on the order how it is connected? LCR, it can be connected in any possible way as long as the value of L and C are constant. The value of resonance frequency will not change. It does not depend on the combination, how they are combined. Okay, they only depends on the factor that the resonance frequency F is given by 1 by 2 pi square root of LC. So L is same, C is same, no matter how you connect. As long as they are connected, it will remains the same. Okay, it does not matter how they are interchanged or not. It is independent of the orientation of the connection of the circuit, right? Next question. The power factor of an AC circuit is 1. Then the phase angle between the voltage and the current is. Okay, so power factor. What is power factor? Power factor is basically cos phi, where phi is the phase angle, right? So cos phi is equals to 1. Phase angle, what will be the value of the phase angle? Simple question, right? So this is only possible when phi is equals to 0 degrees. Okay, so correct answer is option A. As simple as that. Very simple, straightforward, direct question. Power factor is cos phi. If power factor is 1, then this is 0 degree. If power factor is 0, then it is cos 0, cos theta equals to 0. That means the angle will be 90 degrees. Okay. Which of the following is not a reason for energy loss in a transformer? Interesting question. Flux leakage, it is a reason for the energy loss. Eddy current is also a reason for energy loss. Heating effect, it is also a reason for energy loss. And last but not the least, electrochemical effect. Definitely electrochemical effect has nothing to do with the transformer. So basically this is the not a reason. So be careful, not a reason. They have said not a reason. That means you have to identify the wrong answer. Okay, whatever is not fitting to the given condition. So energy loss, these all three options are actually responsible for the energy loss in a transformer, but electrochemical effect is not responsible for any energy loss in a transformer. Next question. What type of material should be used as a core to reduce the hysteresis loss in a transformer? Now hysteresis is no longer part of the syllabus, but hysteresis loss is there in your transformer part as a cause for energy loss in a transformer. And briefly they have also mentioned what type of material is used. So if you read your NCERT properly, you should be able to answer this question. Okay, material with high hysteresis loss, no. Material with low hysteresis loss, yes. Obviously we are trying to reduce the hysteresis loss, so we will try to use a material which has low hysteresis loss, but it should be a conductor. Okay, instead of material the option should be conductor. Now any material can be used, no, any material cannot be used. Only insulators are used. Insulators cannot be used because if you use insulators, flux linkage will be almost 0 due to the conductivity. Okay, conductors basically helps to conduct the flux from one primary to secondary, so that's why the flux leakage is less. If you are using insulators, flux linkage will be very low low, and thus we will lose a lot of energy due to flux leakage. So that's why we do not use insulators, even though the hysteresis loss for insulator is 0. Okay, you cannot use insulators because the flux linkage is almost negligible in that case. So flux linkage will be 0 in that case, and flux energy loss due to flux linkage will be very, very high. So we do not want that either. Okay, so considering everything, material with low hysteresis loss is used. For example, cast iron. Iron is one of the cast iron is one of the material which is used for this, okay, which has very low hysteresis loss. Next, fill in the blanks. Okay, 5 fill in the blanks. Let's solve one by one. The principle of working of a transformer is, let's see options. Phasor, is it a principle? Obviously not. Wattless current? Obviously not. Mutual induction. Okay, mutual induction seems a good option to answer this, right? Because the principle of working of a transformer is mutual induction. They induce current on one another. That's why that is called mutual induction. So basically answer is mutual induction. The power factor of an AC circuit containing pure resistor. Power factor of AC circuit containing pure resistor is 1. Okay, so this is maximum, or you can say this is the you can answer maximum, you can answer 1 also. Unfortunately, yes, it will be 1. It will not be maximum, it will be 1. Both is possible, but maximum, unfortunately 1 is more suitable for this answer. If they say the power consumption, if the question was power consumption, then it would have been maximum. Okay, but power factor, they have specific value, that is 1. A rotating vector used to represent alternating quantities is called. So what quantity can be represented by a rotating vector? Obviously the term is phasor. Okay, so phasor is the rotating vector. The average power dissipated in an AC circuit is if the AC source is connected to a pure capacitor. So average power connected consumed in a pure capacitor is 0. Okay, it is absolutely 0. So no power is consumed in a pure capacitive circuit. That's why it is 0. The current through an ideal inductor is called, wattless current. Okay, it's called wattless current. So there was a term when we were kids in movies and in serials, they used to say wattless. Okay, the villain of the old generation, they used to call the heroes wattless. So wattless means you have no power consumption. Even if the current is flowing through you, you are doing everything, but that is not useful. That is not very good. That's why the term in English, wattless means you are worthless. Okay, instead of worthless, the term that they use is called wattless. Okay, that means you are doing everything, but your work is not making any change. So that is called wattless. So you are waking up in the morning, you are opening up your books, you are trying to study, but in the exam your marks is not getting reflected of your hard work. So basically you are a worthless student if you are not doing that. So whenever you are studying, study properly, focus and concentrate on your all the questions. So that's how you can score maximum number and you will not be a worthless current. Okay, now let's move on to our final part, that is the numerical problems. 5 numericals, super important. All the numericals I will solve in detail. If you still have any doubts, don't forget to mention in the comment below. And also if you want more such content for your PU board exam and your KCET exam, don't forget to subscribe to our channel, like this video and share it with your friends so that our channel can grow. Along with that, we should be able to help you more and more, right? So now let's start with question number 21. A series LCR circuit contains a pure inductor of inductance 5 Henry, a capacitor of capacitance 20 microfarad and resistor of resistance 40 ohm. Okay, if the AC source of 200 volt 50 hertz is present in the circuit, find the impedance, also find the resonance frequency of the circuit. So first of all, let us draw a small circuit diagram and understand what all are given here. So we have a pure inductor of inductance 5 Henry. Okay, pure inductor of 5 Henry. Okay, next is a capacitor of capacitance 20 microfarad. Capacitor of capacitance 20 microfarad and a resistance of 40 ohm. Okay, they are all connected to a AC source of 200 volts. I am drawing this diagram for the first time. From the next time I may not draw this diagram based on the problem to problem. Since this is the first problem I am going to solve, I have drawn the complete circuit diagram. So this is your L, this is your C, and this is your R. Okay, that's why it is called LCR series connection, if you remember. So this is how you should remember. The theory portion of the derivation on everything, that is not part of this. They will not come in your PU board exam, so you can skip that part. But formulas and equations you have to remember. What all the formulas that you have to remember? First of all, they asked you to find the impedance. Impedance means resistance in AC. Right, impedance is basically the term that we use for resistance, but in an AC circuit. How it is different in case of a normal circuit, a DC circuit and AC circuit. So for example, in a DC circuit, the resistance of L can be considered to be 0. Similarly, for a DC circuit, resistance for a capacitor can be considered infinity. Okay, but for AC this is not, so we have to consider all the values. So first of all, there are two types of reactance. Reactance is same as resistance again, but this is used for only terms like inductance and capacitance. Okay, inductive reactance, capacitive reactance. Okay, inductive reactance, since we are solving it for the first time, again I am explaining everything. Inductive reactance is basically XL, yes, inductive, and it is given by omega L, where omega is the angular frequency. Omega is angular frequency, but most often you will not see the problem or the formulas, they will not give you omega. For example, here they have given 50 hertz. What is the unit of omega? Unit of omega is radian per second. Is it given in radian per second? No, right? So how to tackle that? We know that omega equals to 2 pi f. Okay, so omega is 2 pi f, f is the frequency. So now we have converted our formula into the given value, that is in terms of the frequency hertz, right? So let's put that value. So we can calculate XL in the given question is 2 pi, okay, f is 50 hertz, and what is the value of L? L is given 5 Henry. Okay, so what is this value? 2 pi times 5 is 10 pi, 500 pi. For now I am not inserting the value of pi right away. We will see, and later on we will use it, as we will do in future problems as well. So pi value I am keeping it as pi. Now inductive reactance is XL, and there is capacitive reactance as well, and the unit for inductive reactance and capacitive reactance both are ohm. Okay, they are basically resistance in AC. What is the value for capacitive reactance? Again it is 1 by omega C. Okay, it is 1 by omega C. Again, how to convert that? We will do that by doing 1 by 2 pi fc. Okay, now let's put the values. 1 by 2 pi is obviously 2 pi. 2 pi is 2 pi, right? F is 50 and the capacitance is given 20 microfarad. So be careful, they will always be given in terms of microfarad, nanofarad. So you have to adjust the 10 to the power value. Okay, so you have to adjust the 10 to the power value. Now let's see, this 10 to the power of minus 6 will go up and become positive. Whatever in the denominator, 2 pi, 50, 100 pi, 100 pi times 20, 100 pi times 20 is 2000 pi. Okay, so it will be 10 to the power 3, so this will be 500 divided by pi. Okay, how it is so? So first of all, what we will do, we will cancel these 3 zeros and 3 zeros from the top. Okay, so these 3 zeros are cancelled and 2 is remain. Now 10 to the power 3 means 1000 divided by 2 pi equals to, so it will cancel, you will get 500, so it will be 500 divided by pi. So we calculated XC, we calculated XL. XL is 500 pi, XC is 500 divided by pi, and resistance of the circuit is given 40 ohm. Okay, so resistance of the circuit is given 40 ohm. Now what is the impedance? Formula for impedance is given by Z. Z is impedance, and this is given by square root of, very important, okay, R square plus XL minus XC whole square. Now in some problems you will find XL is more than XC, in some problems you will find XC is more than XL. They have some physical significance. Okay, for example, if XL is more, the circuit is said to be inductive. If the XC is more, circuit is said to be capacitive. For example, in this case 500 pi is definitely more than that of 500 divided by pi. So we can say that circuit is inductive. But this symbol, because they have a square outside, it does not matter whether it is XL minus XC or XC minus XL. So what you have to do, you have to calculate XL and XC, then you have to subtract the more value from the less value. Okay, understood? So for example, what we will do here, we will do XL minus XC. Okay, so 500 pi minus 500 divided by pi, or LCM is pi, so 500 pi square minus 500, right? So 500 will be common, we'll get pi square minus 1 by pi. Okay, so pi square is approximately 9 point something. Okay, minus 1 is 8 divided by 3. Okay, so you will get some approximate value. You can calculate the using your calculator what will be the exact value. Okay, for me the value will be almost equals to 3. With this entire pi square minus 1 by pi will turn out to be almost equals to 3. So you can take that as 1500 ohm. Okay, so this is the value of XL minus XC. Now what is the value of R? R is 40. So you have to do 40 square plus 1500 square So if you calculate this entire thing, you will get this value to be 1412. Sorry, I am taking a shortcut because I am not using any calculators. So you can calculate this value using your calculator, which is allowed during your PU board exam, and you can calculate this value. Now let's calculate the resonance frequency. So what is the formula for resonance frequency? I discussed it. The resonance frequency is given by 1 by 2 pi square root of LC. So same formula, okay, use this formula to calculate the resonance frequency. 2 pi, okay, what is the value of L? L is 5 Henry and C was 20 microfarad. So don't forget to put this as well. Microfarad means 10 to the power of minus 6. So it will be, see, only one thing is very irritating in such cases is that this pi. Okay, be it in the multiplication, be it in the division, but it has a value. You can use that value using your calculators. Okay. So don't afraid of that. Now 10 to the power of minus 6 was inside the square root. I have taken that square root outside, so it will be 10 to the power of minus 3. It becomes half, right? Now 100 square root is 10 square. 10 square is basically 10, or 100 square root is anyway 10, right? So it will be 10. Okay, so now you can cancel one more here. So you will get 10 to the power of minus 2. So 10 to the power of minus 2 will go up and become 10 square divided by 2 pi. So it will be 100 by 2 pi, or it will be 50 by pi. Okay, if you calculate it, it will be 15 point something, which is very close to 16 Hertz. Okay, so this answer will be very close to 16 Hertz. Okay, it's close, it's okay. Okay, you just use your calculator to calculate the final values. You should remember the steps. Okay, you should remember the steps. First of all, to calculate XL and XC, you will get marks. Okay, 1 mark each for calculating XL, 1 mark for calculating XC correctly. Okay, that is very, very important. And you will get, if you calculate everything, and then if you calculate the Z using the formula, if you insert the formula inside the formula correctly, you will get 1 more mark. And to calculate this value correctly, you will get 1 more mark. And for resonance, you get 1 mark. Okay, so including everything, you will get 5 marks. So be careful when answering such questions. Even if you your final answer is not matching, even if your final answer is not matching, okay, if you have done calculated XL and XC properly, okay, without any mistakes, with your patience, then definitely you can score marks. Okay, even if your final answer, suppose you have made some mistakes while calculating Z, okay, and your answer is not exactly matching this, you will still get marks. Okay, so don't be afraid. And more importantly, the second part of the question where they asked you to calculate the resonance frequency, it is independent of the previous calculations, right? So even if you have calculated this value incorrectly, you can score up to 4 marks from this numerical, even this answer is not matching. So don't get disappointed if your problem answer does not matching or is not matching with your friends. Okay, maybe your friend made some mistakes, okay, or maybe even if that is wrong, you can still score a good decent mark from the numerical. Okay, so solve the numerical are important rather than the answers. Okay, practice more and more numericals. This kind of exactly same kind of problems are there in your NCERT book. Practice from there with different values. Just train your mind. I saw many of them writing the formulas correctly. When they insert the values inside the formula, they are not able to handle that equation. Okay, that becomes complicated. So that is one of the issue that I have observed, especially from this chapter. Okay, even if they have written these formulas correctly, they are not sure what to do after I insert these values. Okay, if you are one of those, then you have to practice a little bit more. Okay, practice whenever you can, insert the values, check if you are getting the resonance frequency or not. Okay, now this is another question. This is also from the chapter AC as usual. An AC source of frequency 50 Hz is connected in series with an inductor of 1 Henry, a capacitor of 90 microfarad and a resistor of 100 ohm. Does the current leads or lags the voltage? Calculate the phase difference between the current and the voltage. So this is a different type of question, okay, where the question is not super direct that calculate the impedance, etc. Calculate the impedance might come, okay, from this question also, but here as because the HOTS question is possible, but this is also a fixed pattern. Okay, this is a HOTS question question, but the question is a fixed pattern. You can answer this question if you know how to solve it. So first of all, always remember, if they have given you C and L, okay, and they do not ask you directly calculate resonance frequency, they have asked you anything else, okay, then always calculate XL and XC. XL and XC is compulsory. How to calculate XL? 2 pi f L, right? What is 2 pi? 2 pi is 2 pi. F is 50 Hertz in this case. Again, 50 Hertz frequency is given. And what is L? L is 1 Henry. So this value is okay. Easy value. So XL you can calculate is 100 pi. Okay, or 314.1, that is fine. What is XC? Calculate XC next. XC is 1 by 2 pi FC. So let's put the values. 1 by 2 pi, F is 50, and what is C? C is 90 microfarad. 90 times 10 to the power of minus 6. Okay, so it will be 10 to the power of 6 divided by 100 pi times 90. 100 times 90 is 9000 pi. Okay, so again you can cancel 3 zeros from top and 3 zeros from bottom. It will be 10 to the power of 3 divided by 9 pi. Okay, so it will be 1000 divided by 9 pi. Okay, so it will be approximately, see again, if you see approximate value, 100 pi is 331. If you calculate the value, it will be 314.1 approximately. Okay, ohm. Okay, and what is the approximate value of this? So this will be approximately 1000 divided by 28 approximately. So it will definitely be less than this value. Okay, it will be definitely less than this value. 14,500 250 by 7. Okay, 46, about 36 ohm. Okay, approximate value is 36 ohm. So capacitance XC is more than that of XL. Very important. Sorry. XL is more than that of XC. So the circuit is inductive in nature. The circuit in this case is inductive. As I said, if XL is more than XC, the circuit is inductive. This can come in our objective question, MCQ as well. Circuit is inductive. Okay, the circuit is inductive. So inductive circuit means we know that in case of pure inductor, the current lags the voltage, okay, by an angle pi by 2. In this case, even if this is a not pure inductive circuit, okay, it's because the circuit is inductive, current will lag. Okay, current will lag. By how much it will lag? Current will lag the voltage. By how much it will lag? That can be given by tan phi equals to, so they have also asked you the phase difference. Phase difference is XL minus XC divided by XL minus XC divided by R. Okay, so tan phi is basically XL minus XC divided by R. If the circuit is capacitive, then it will be XC minus XL. That you have to remember. Okay, so it will be 314 minus about 36 divided by R is, what is the value of R? 100 ohm. Okay, so it will be approximately 270, approximately 270, no, not 270, 280 divided by 100. It does not matter, you can calculate the exact value using your calculator, so no issue. Okay, 2.8, and if you calculate the phi, will be tan inverse 2.8. Okay, so this is the last answer. If you have the calculator, scientific calculator is not allowed, so you cannot calculate the exact value of this. If you know the answer, you can write. If you don't know the answer, you can leave it here, you will get full marks. Okay, don't worry, you will get full marks. So as you say, current lags. Okay, also you have to mention in here, circuit is inductive, thus current lags. Okay, so you have to mention this line to get 1 mark. Be very, very careful. You have to write this line. This is a very important one line. So you don't need to do any calculations. Once you have calculated XL and you have calculated XC, you have to write this line. Thus, circuit is inductive. You have to mention XL is greater than XC and the circuit is inductive. Thus, current lags, because in an inductive circuit, current is lagging behind voltage. Right? If the circuit was capacitive, then current would have leading. Okay, so if this problem in the problem, if you solve it properly, then you get the value such that current lags, then you will get XC is more, then you can say current leads. So be careful in this problem. After solving everything, you realized the value of XL is more than that of XC, so circuit is inductive, thus current lags. And by how much it lags, for that you have to remember this formula. This is a new formula that we have introduced in this problem. Tan phi equals to XL minus XC divided by R. Okay, and calculate exact value. Okay, and then you can solve this problem. I have done a lot of approximation, still my answer is very close to the original answer. Okay, and it will be approximately 70 degrees. Okay, this part is optional, not compulsory, because you are not allowed calculators, and if they give this kind of values, this problem is taken from one of your previous year question paper or blueprint. Okay, so if they give you this kind of problems, you have no other option, you have to leave this like this. Okay, if you scientific calculators are used, then you can calculate this value. Right, now let's move on to the next question. A sinusoidal voltage of RMS value 200 volt and frequency 50 Hz is applied to a series RC circuit. So it is only RC circuit. Okay, frequency is 50 Hz, resistance is 3 ohm, capacitance is 800 microfarad. Calculate the impedance of the circuit and the current through the circuit. Phase difference between current and voltage. So there are 3 different parts. Okay, first of all we have to calculate the impedance. To calculate impedance in LCR circuit, what was our first step? So calculate impedance in LCR circuit, our first step was to calculate XL and XC. Now here we are only talking about RC circuit. So first step is to calculate XC. This will be always our priority, be it RC circuit, be it LC circuit. Finding XC or XL is always will be our first priority. Okay, 1 by 2 pi FC. Okay, just put the values. Okay, and we know that if the frequency is 100 Hz, the term 2 pi f becomes 100 pi. So I will write at that directly. And what is the value of C? C is 800 microfarad. So 800 microfarad means 10 to the power of minus 6. Many students ignore this term microfarad. Okay, so be careful, don't ignore this. Microfarad is also important, and for that you have to add a term 10 to the power of minus 6. Okay, now if you see, there are 1 2 3 4 zeros where there are 10 to the power of minus 6, that means division. So what we will do, we will reduce it by 4. So it will be pi times 8 times 10 to the power of minus 2. Okay, or this will go up and will become 100 by 8 pi, something new. So far it was always 100 by pi or 200 by pi, something new we have received, right? So it will be 25 to So it will be 12.5 divided by 3.14. Okay, so the approximate value will be 4 ohm. Okay, you can calculate that and you will get this answer. If you don't get the answer, mention that to the comment below. Sir, I have used my calculator, but the value is very far off from 4 ohm. Okay, so if you are practicing for cassette, obviously then you should know how to approximate the values, right? So 3 is here, 12 is here. Okay, we can for some time we can ignore this 0.5 and 0.14 and we can see that 3 4s are 12. So approximate value will be 4 ohm. Now what is this is the Excel. Now first step is to calculate the impedance of the circuit. How to calculate impedance if there is no L? Simple. If there is no L, put XL equals to 0. That is, impedance is equals to R square plus XC square. You cannot add them simply. You have to use this formula. Okay, R is given as 3 ohm. So 3 square plus 4 square. Now can you tell me the answer in one line? By the time I am solving it, can you tell me the answer for this? Those who still typing, they are too late. I have solved it. Okay, 3 square plus 4 square equals to 5. Square root of 3 square plus 4 square. Okay, so those who have solved a lot of Pythagoras theorem problem in your previous classes, they know this. Okay, so 3 square plus 4 square square root is equals to 5 ohm. So the impedance of the circuit is 5 ohm. So first answer, you have to mention that in the answer. Okay, 5 ohm is the impedance of the circuit. Now the current through the circuit, so voltage is given 200 volt RMS value. So the RMS value of the current, they have not mentioned anything. That means RMS current only we need to find. That is 200 divided by 5, 40 ampere. Okay, 40 ampere is the RMS current in the circuit. Now phase difference between current and voltage. Now we have seen one formula for phase difference, where the phase difference, we said phase difference is basically XL minus XC by R, but in this case XL is not 0, XL is not there, so XL will be 0, and because only XC is there, we will ignore the negative sign as well. So our answer will be XC by R only. Okay, so it will be XC by R. What is XC? XC we know is 4. Okay, what is R? R is 3. Just put the values. So tan phi equals to 4 by 3. So phi equals to tan inverse 4 by 3. Now there is no harm to leave this answer here to get full marks. This is part 2. This is part 1. Okay, that is part A. This is part B. And this is part C. Right? Now there is no harm if you leave the answer here, but this is a very known value. Okay, those who are preparing for any competitive exam, NEET or JEE or KSET, they should know this is a very special angle. Okay, tan inverse 4 by 3 is 53 degrees and tan inverse 3 by 4 is 37 degrees. Okay, these two are complementary angles. Okay, I have done one video on this during our basic mathematics class. If you have observed that, there I have explained this value. So this is very important. So you can say that the value is 5 ohm, 40 ampere and 53 degrees. Okay, but this is also acceptable. Not everyone is preparing for JEE and NEET exam or KSET exam. Someone wants to study general science, so they may not know this exact value. So 53 degree or tan inverse 4/3, both are acceptable. You will get full marks for this. Next, Question number 24. A resistor of 50 ohm, a pure inductor 250 millihenry and a capacitor are connected in a circuit. So they have not mentioned the capacitance, okay, are connected in series in a circuit containing an AC source of 220 volt and 50 hertz. In the circuit, current leads the voltage by 60 degrees. Find the capacitance of the capacitor. So this is also a little complicated question, but only one part question. Generally from this chapter, one part questions are very rare, but this question came as only one part question. So we will solve this by step. First step, always remember, if the circuit is not in a resonant condition, first thing you have to do, you have to calculate XL and XC. Okay, that is the first step. So circuit is not in a resonant condition, so first you have to check if the circuit is in resonant condition, anything about resonance is there or not. No resonance mentioned, so that means first step is to calculate XL and XC. Now C we do not know, so we will not calculate XC. L is given, so we will calculate XL first. Okay, 250 millihenry. So L is 250 millihenry. We know that 2 pi FL, that is 100 pi. Now tell me why I have written 100 pi. Okay, so after solving so many problems, you don't need to waste time on that. You can directly write 100 pi. Now milli means 10 to the power of minus 3, micro means 10 to the power of minus 6. So these are very small things, easy to ignore, but you should not. So now you can see that 10 to the power of minus 3, this 0, 1 0, 2 0, 3 0. So you can easily cancel all the zeros and you can say, okay, goodbye 10 to the power of minus 3, tata, see you in the next problem. So we will write this as 25 pi. Okay, so this is gone. 25 pi is the XL. Now what is R? R is given in the circuit is 50 ohm. So what is the phase difference? We know that phase difference, if the phase difference is phi, then we know that tan phi equals to XL minus XC by R. Now in this case they have said that current leads the voltage. Current leads the voltage, so there we have to be slightly careful while using this formula. Why? Because current leads the voltage means it will be XC minus XL. Okay, if you remember in our previous problem where we solved a similar question where we used to determine whether current is leading or lagging, so that case we found that XL was more than XC, so we said current lags. Now there they have mentioned current leads the voltage, so this also has some meaning, right? So what is the meaning of current leads the voltage? The meaning of the fact that current leads the voltage means XC is more than XL. So while writing this formula we have to rearrange, we have to be careful in our head, XC minus XL, right? Now tan phi is given as 60 degrees, so we simply put the value as 60 degrees. Tan 60 degree we know the value, so XC we don't know, XL we already calculated 25 pi. And R we know is 50 ohm. Now what is the value of tan 60 degrees? Okay, tan 60 degree is sin 60 by cos 60. So the answer is root 3, right? So tan 60 is root 3, tan 30 is 1 by root 3. So these two values are very well-known values, right? 25 pi. I am making some mistakes, small silly mistakes. Sorry for that. So it is minus 25 pi. Actually 5 and pi are so similar, I am making this mistake again and again, right? So now continue our calculation in that. Okay, so XC minus 25 pi equals to 50 times root 3. Okay, so XC is 50 root 3 by plus 25 pi. Now what is xc? xc is 1 by 2 pi f c, right? So this is the value of xc, we know that. Now what is c? From there we can say 2 pi f c is basically 1 by 50 root 3 plus 25 pi. You can put the values from there. Obviously 2 pi f is nothing but 100 pi, right? We know that f is 50 given. In most common frequency is f equals to 50. Okay, so we know that this is nothing but 100 pi. So from there you can calculate the value of c using your calculators. Okay, and you will get the answer to be 20 microfarad. It will be approximate value. Okay, check if you get the value 20 microfarad or not. Okay, tell me in the comment below if the value is matching with 20 microfarad or you are getting something else. Okay. Now question number 25. This is also very interesting question. Okay, I have taken this question from some of the midterm question paper. Okay, very interesting but not super difficult. Question paper is something similar to the previous question but it is different. A sinusoidal voltage of peak value. So here they have given you the peak value, not the RMS value. Generally 220 volt 50 hertz means 220 volt is representing RMS value, but here they have mentioned this is the peak value. So very careful. Is applied to a series LCR circuit in which a resistor of resistance 5 ohm, a pure inductor of inductance 32 millihenry and a capacitor of capacitance 800 microfarad are connected. Okay, so they have given you resistance, they have given you inductor, also a capacitance. Okay, and they asked you first find the resonant frequency. So if the resonant is not mentioned, then you could have calculated XL and XC, but first step is to calculate resonant frequency. So we will do that. So first we will calculate resonance frequency, then we will see the questions next. So what is the resonant frequency? Resonant frequency is 2 pi obviously 2 pi f is f we have already taken, so 1 by 2 pi square root of LC, right? Let's insert the values. 2 pi square root of L is 32 millihenry and capacitance is 800 microfarad. Okay, so it will be 1 by 2 pi square root of 32 times 8 is 256 times 1 2 minus 3, it will be cancelled. 10 to the power of minus 9, 10 to the power of minus 9 times 10 to it will be 2 zeros less, so 10 to the power of minus 7. Okay, so the answer will be 10 to the power of minus 7. So if you calculate everything, the frequency you can calculate using your calculator. Okay, and I hope you will get the answer frequency to be 10 hertz. Approximately 10 hertz will be the answer. So this 10 to the power of minus 6, how can you solve this? I am telling you one hint. First of all, you can take this 2 pi times 256 is square root of 16. Now you can take that to be square root of 0.1 and 10 to the power of 3. This is the way you can calculate, you can check this answer. Okay, 10 to the power of minus 7 means square root of 10 to the power of minus 7 means square root of 10 to the power of minus 6 times 10 to the power of minus 1. Okay, so you can keep this, you can take this outside, so 10 to the power of minus 3 and it becomes 0.1. 1. So that's how I have written this. Okay, clear? Now this will go up and become positive, and you can calculate this exact value of the resonance frequency. Now calculate the impedance and power dissipated at resonance. So again, do we have to calculate XL and XC? This is the trick. This is the trick. So this is a very easy question. If you see this question, your eyes should lit up. Only part, yes, this part you have to calculate. All cases of AC related problem, this pi creates a problem. Okay, generally they don't give you in terms of angular frequency. If they give you in terms of angular frequency, definitely pi value is no longer required. So all the problem is super easy. But other than this pi factor, if you see this problem, your eyes should lit up. Why? Because in case of resonance, power dissipated in resonance, calculate the impedance and power dissipated at resonance. So both are to be calculated at resonance. Now at resonance, the most important thing is XL is equals to XC. So the impedance is basically only resistance R at resonance. At resonance, you have to mention this term XL equals to XC. Okay, so when the resonance happens, XL becomes XC. So inductance, capacitive reactance and inductive reactance both becomes equal, both cancel each other. So that term containing XL minus XC, that becomes 0. So Z becomes directly R. So impedance is 5 ohm directly, don't worry. Okay, so the impedance is directly 5 ohm, and what is the current? Current is basically V by R. Okay, but here one trick that you have to remember, since they have given you peak value, okay, to calculate current you have to use this formula, V by 2Z. Okay, since they have given you peak value, you have to remember 220 volt divided by 2 times 5. So this is because we have to V square power dissipated, right? We are not calculating current, my mistake. We are calculating power dissipated. Power dissipated is V square by R. In this case, V square by Z, because impedance is Z, right? Or Z, whatever you say. So impedance is Z, so that's why V square by 2Z. Now if you put the value, you will get 48400 divided by 10. One of the zeros will cancel. So 4840 watt. Okay, so in impedance, if they give you any problem related to resonance, so that should, your eyes should lit up, because in resonance, except the calculating the resonance frequency, impedance itself only is the resistance, and current is basically Vrms by R, power is Vrms square by R. Okay, so that two things you have to remember. So in this problem, they tried to make it complicated by giving you peak value instead of the RMS value. Okay, if they have given you RMS value, this would have been much more easier. Okay, so this is the few tricks, few tips that you have to remember to answer the one sure shot problem from this chapter. Okay, and I recommend every student to practice more numerical questions from the chapter alternating current. And if you have liked our video, don't be a direct current, become a current like alternating current. Like, share and subscribe this video, and I will be back with a new topic, new chapter in our next class next week. Till then, bye.